again. Hello, guys.
Alright.
Hello, who joined us recently. Thank you for staying with us from the previous discussion, previous talk. We are continuing our Mobile People Community Day. Today we have a final talk according to our agenda. It's related building a perfect, pixel-perfect augmented reality application with help of neural networks from the scratch. But before we start with this talk, let me say a few updates. After this talk, we are having a quiz in Kahoot, and we present for winner of this Kahoot quiz. We have a special present from course from Udemy. Winner can choose this course, and we pay for it. And don't forget that we have here a YouTube subscription, a YouTube broadcast stream. Yeah, it will be recorded and will be available after a week on this channel. And you can ask here us any questions that related to the topic or Android or any mobile disciplines. We will try to answer on them. Don't hesitate to ask everywhere you want in VR community chat or YouTube channel. Also don't forget to subscribe on VR community channels. Mobile People Community Day. Happy to see you all. We have many events and conduct streams and different talks. So let me introduce speakers that we have for talk Neural Network Inferno, Nevan Circles of Hell. Sounds a bit scary. Vyacheslav Katsuba from Gomel, Belarus, lead software engineer. Hi, Vyacheslav. And Sergey Bondarenko, chief software engineer, Kharkov, Ukraine. And the first small question from me to you, how many augmented reality applications you actually you have on your mobile phone?
Probably only the one I am developing, as from my side. And it's a really tricky question because, for example, should you count Mask in Instagram as augmented reality application or no? So I think that
many
AI
people doesn't know that the
Right.
application has this functionality. I agree. It's
Well,
difficult to count.
From my side, I'd say right now, only similar like Sergey, those that bind it up inside already existing applications. But during all my work time, I'd say it's about 5, including 4 that I made by myself for different vendors and for different clients.
Thank you guys for sharing it. Let's proceed with your presentation, please. The stage is yours. Please share your ideas.
Yeah,
Yep.
at last. Thank you. Awesome. So, sorry for technical inconvenience. At last, I can continue. Our talk is Neural Networks Inferno, 9 Circles of Hell on Android. We had pretty interesting discussions from previous speakers, and they were discussing how would neural networks work in future. But I can tell you how interesting it is implementing them now. And about circles of hell, you should pass while doing it. Okay, so let's go with our talk. So, quick introduction, who we are. My name is Sergey Bondarenko. I'm Chief Software Engineer in EPAM. Overall, 10 years experience in IT and 6 years of experience as security engineer. My co-author is Vyacheslav Katsuba. He has also more than 10 years experience in IT, and he's a very technical person. My part of talk will be more general, and Slava's part of talk would be more technical. So the first circle of hell we went to was desires of client. Basically, its requirements and what we should do. So I will tell you a bit about that. We needed to make augmented reality application that attaches some details to person face in real time. And the trick was that we needed to have great performance for neural networks. So we needed to have 30 FPS on the screen. So we need each frame to be prepared and shown in less than 33 milliseconds. And another tricky moment that it should be pixel perfect, and so the neural network was pretty big and pretty complicated. And we passed to the next circle, domains of choice. And basically, it's our start of writing this application. After discussion and small researches, we decided to stick up to classic libraries by Google. So for finding faces, we used MLKit. We had a Kotlin coder that is rotating picture and cropping it. After it, we were proceeding it with neural network on PyTorch. We started with PyTorch because it was a request from our data science stream. After that, we applied cosmetics or some augmentation to human face, rotated back, and have drawn it on standard Android canvas. And it was working, but it was very, very slow. This whole setup was taking us something like 3 seconds for each frame. And we have found that we need to evolve and do more choices. So we started with MLKit, taking into account and taking researchers Camera X, OpenGL, PyTorch, TensorFlow, and MediaPipe. All of these frameworks were used on our project during some time, and we were switching from one to another when we were finding some showstoppers in each of them. It was really complicated, and I have also a diagram that shows a part of life cycle and modification of our project. So here it is. It is partial. Here you can see kind of small quick evolution, how we started. At first, we were having 2.5 or 3 seconds for frame. When we optimized operations in Kotlin, we have sped up to 1.5 seconds to 2 seconds. After that, we switched to TensorFlow Lite. It gave us great boost in performance, and we generally the problem with PyTorch was that we couldn't switch neural networks counting on mobile device to GPU or TPU. When we faced it and found that out, we have switched to TensorFlow because there are opportunities to switch to GPU. After some time, we changed MLKit to MediaPipe. It gave us additional performance and dropped camera and used MediaPipe. After additional time, Slava made some magics in OpenGL, and we moved to 200 or 300 milliseconds to frame. So basically, we had kind of 4 frames per second. It was not enough. We have deep diving into MediaPipe and found out that MediaPipe inside itself has a TensorFlow. So Slava did additional magic optimization, and we moved to kind of 10, 9 frames, something like that. it's already, we are in kind of happy part of the story. And after that, we used, we did additional optimizations that would be covered in future slides, and optimized buffers and introduced additional neural networks with lower quality for lower-end devices. But this is the endpoint, and now I will tell you some interesting information that we faced during this application research. So the next circle of hell is false teachers. Basically, on this screen, you can see how neural network API in TensorFlow should work. It's awesome idea. I really like it. In generally, you have hardware abstraction layer, and when you launch, for example, the same neural network on different devices, for example, on Pixel, Samsung, or Xiaomi, it should take a look at the manufacturer of the device and the drivers that are installed, and it should itself decide what solution would be quickest. For example, on Pixel, it should select Tensor chip to run neural network, and for example, on Samsung, it should select GPU to run neural network because it would be quicker. So here is how it should work, and no, it's not working this way. At least it wasn't working this way previous autumn when we did some researches. Just no. So the next circle of hell is rough, because we were first we were thinking that we are doing something wrong, and probably it's a common problem or something like that, and we should find it out. So first we checked Stack Overflow related to TensorFlow. After that, we have taken a look into TensorFlow on the GitHub, taken a look at the issues that might be related, found several that might be but might not be related, because it's pretty complicated sometimes, especially with cross-stream cooperation and so on. After that, we opened topic on the TensorFlow forum that we have problems that our neural networks, while using an NLP on Android, it uses fallback every time, but it shouldn't happen. We had several answers and suggestions. Yeah, I should thank you to those guys because they answered pretty quickly, but none of the proposals that they did to us wasn't working, none at all. So we didn't find out how to make it working. So we have took additional time for research and found interesting application. It's called AI Benchmark. We used it to run our neural network for researchers. It did show some good results, better than we had using standard TensorFlow, and it was a question how they did it. So we reversed application and have taken a look at it, and found out they are using some non-standard TensorFlow build with non-standard hashes, and there is no such build of TensorFlow in the release of TensorFlow. I have no idea where they have taken it, but it was working. And it's linked to some additional SDKs for running neural networks, for example, Samsung Neural SDK. And when we tried to take a look at it and implement, for example, Samsung Neural SDK for Samsung devices, we found out that it's private now and we cannot access it. So this was one more dead end, and we have moved to another circle of hell. Grid. We needed to do some performance, but we didn't know how. And we found we have ended writing our own application for testing neural network because we didn't found exactly what we need anywhere in the internet, including some TensorFlow test applications. The application is pretty simple. You can dynamically switch to use an NLP CPU or GPU. It was running neural networks 100 times and counting maximum, minimum, and average time when it's running. We have done we have implemented several neural networks from our data science stream, kind of, as far as I remember, more than 15, probably something around 20, with different architectures, different input size, and so on. And we were just testing them on the whole zoo of our test devices and all available devices. Here, I have censored some pictures that might be under NDA with black boxes. Sorry for this guy, but you understand the NDA. And we got table with results. Results were pretty interesting, and some of them were really unexpected. For example, some architectures are crashing on some devices, and sometimes it's pretty hard to predict. And for example, here you see that some neural networks might run in 7 milliseconds, just an example, on Pixel, and they might take, for example, 60 milliseconds or 70 on Samsung. And it was really unpredictable for us, but generally, after we have done this table, we had more than 200 measurements for our 11 devices. You can see devices here. Basically, we were selecting devices to cover different Android versions, manufacturers, different GPU chips, and different OS versions, and so on. For example, Android from Xiaomi, Android from Samsung, and the clean, great Android 2. And after that, we have analyzed the results and basically just selected architecture that was the quickest in general on average numbers. Probably my part of story with low technical details is ending here, and I'm giving word to Vyacheslav.
Yeah, thank you, Sergey. So, hi again, guys. I worked on this application as technical lead, and having neural network in your application, it's kind of cool, but at the same time, it's very complex because you need to count a lot of stuff. So a lot of things should be on your mind at the same time. We have different approaches, different tries to achieve the most perfect result we can. And if you take a look at the slide I'm showing right now, so this is the devices we have as our most powerful devices. And having the first results were really fun for us because we see that Pixel devices mostly show us 30 FPS, which is our target FPS we want to have. But then we start testing on another kind of devices like medium tier and lower tier devices. And here where the things go somewhere in the wrong direction. Because very popular kind of devices in Xiaomi and Samsung's have pretty low performance, and it wasn't good option for us. And some kind of devices just having constant crashes. Here you see the results of one of our most, I'd say best results we had a few months ago. We achieved them with our blood, I'd say, because amount of time we spent to searching information and working with different sources, we deobfuscate original code from different applications for testings. We dive deep inside TensorFlow, source code to find any tricks that we can use to achieve some speed. And we find out that not just TensorFlow is a part that slow down the performance, but we also need to work with the data, how we processing data, how we pass data inside TensorFlow, and how we bring it back. So it were really hard times, but we had to do something, and we start from analyzing what we have, what we can improve. It works. It works somehow, which is pretty good, but still we need to make it better, because somehow it's not how we work. It should work good. So first we take the really low-end tier device, the slow one, and took as much accurate timing from these devices as we can. And as you can see, a lot of time used to process our neural network models. But at the same time, there is some time gaps around the data that we pass into neural networks. So here is a point we could probably improve to get results, because neural network itself, it's not a place we can just improve, because it's about library. Just a simple example, with the newest updates from TensorFlow, we able to avoid some memory leaks that we have. So it's really crucial to keep your version of TensorFlow library updated, because there is a lot of fixes. It's constant releases. The guys doing a really good job. So where we look, what we have in the digits. So first of all, we couldn't improve the speed on how we take in frame from camera, because it's not a place where we can do something. It's just a system. But preparing information to pass further into neural networks, it's a place we can improve a lot. So here we have OpenGL code and compute shaders that process all this information. We get deep dive into documentation, into different processes, how to achieve the maximum speed from these compute shaders. Like very fun stuff is preparing frame and reading the information from this frame in different passes of OpenGL. Works about 5 times faster than compared to doing it in just one by one. Something about specific of OpenGL, which I won't dive deep. So next part is about cropping our data that we having from our networks. Just a small example of amount of data we had to process. Our model provides us 2 pieces of data, as you can see at the right top side of this slide. It's about 500 points, which is not a lot, and 13 textures, which is really 5 megabytes of data. So just imagine that we had to process about 8.5 megabytes of data each frame, 30 frames per second. It's a lot. So the most complex part of this algorithm were to process data. And yes, we talk about neural networks, but you still need to know a lot. You need to know how to process data. You need to know algorithms. What is algorithm complexity? A lot of things should be counted just by having this stuff in your application, because just running model is simple. It's really simple. Processing data and work with complex solutions is much harder. So you have to work with it really accurately. So as you can see, we have 5 generations of one algorithm. We start from 200 milliseconds, which is really huge, because 200 milliseconds lead us to maximum 4 frames per second on our screen. And having different iterations, different optimizations with OpenGL compute shaders, with using multi-processing, with using more than 10,000 threads on the GPU of the device, lead us to 10 milliseconds, 20 times faster, which is really incredible, especially for these kind of devices. So the joy of this process is, of course, watching how other people fixing it, but unfortunately for me, it was me who fixing this kind of issue. A really complex part where you need to have your vision over wide amount of things. Like you need to understand how this TensorFlow works, because under the hood, inside this open inside this TensorFlow, it is something like OpenGL. It is compute shaders or their representation in different languages. So you had to know this stuff if you want to achieve the best results, not just simple application that detect the kind or simple stuffs in your image. If you want to make really cool application, you had to have wide vision and wide knowledges. So the tools we used, just out of scope from Android Studio, there was mainly, I'd say, 3 tools. The first one is Android Studio itself with flame charts, with recording traces from system and so on, which show us the processing time of special functions. So this is how we measure the functions that slow us down. The second tool were Android GPU Inspector, which convert OpenGL calls to Vulkan calls and able to record these calls. So having this tool, we were able to record all the OpenGL operations that happen inside our code. Because how OpenGL itself is working, it's building a stack of commands and then executing. So if we just try to track it from the code, we will see the time to add the command into stack and not the actual time of executing this command. So that's why you had to use some special tools to reckon this kind of information. Or there is a tricks, but we kept them secret. How GLSL compute shaders work itself, our GPU have cells which have some amount of threads, and you may have multiple amount of these groups, word groups. Each of them have the threads you can run, you can use, and this is how you can achieve like 10,000 threads in parallel. Of course, synchronizing this amount of threads is really hell, and you had to understand how it works, but why do we care? Because we had to do it. Okay. So diving deep into these compute shaders, we find out timing for each shader. Here a screenshot. This is really a screenshot from work in process where we find out where is shader and where is timing. And we share it in between our team to say, hey, I found this shader took too long. We can try to optimize it. This is the point we could improve. And there was really huge brainstorms to find out how it works, how can we improve various points, reading documentation, rising up our OpenGL version from version 2 up to version 3.1, if I'm not mistaken, but I hope no. And one day, one time, we finished. We did most of the work to optimize. And as final output, we find out that we win about 35 milliseconds. At first time, it might not be that like cool, but first iteration, low tier device, we have 70 milliseconds. After our optimization, we had 35 milliseconds, 2 times faster working application. And this is the most interesting stuff. Why do we take lowest tier devices? Because higher tier devices will have almost same amount of optimizations, yet because of TensorFlow itself working way more faster, because there might be more powerful GPU, it might be TPU processors that will rise up the speed, we still have this optimization actual for all kinds of devices. And here where we have the most impressive point. If we take low, medium, and medium tier devices, we rise up from about 15 frames per second, which is very laggy, up to about 20 frames per second, which is almost not feeling laggy. And these 5 to 7 frames that we won on low, medium, and medium tier devices were really impactful, because having this improve makes our application from laggy to acceptable, which is really good. And of course, for high tier devices, we didn't have this kind of huge amount of performance boost, yet we have battery optimizations, because the faster and the optimizer we have our processor, the less frames we need to process, and these gaps in between frames might be a power save points. So this is how we work with neural networks. This is circles of hell will pass, and I hope that no one will face same amount of pain and will have this kind of information, maybe better guides, or come to us. Thank you, guys. This is all from me.
Yeah, thank you.
Thank you guys very much for the exciting and I could say challenging talk. Probably we have to rename it by on 10 circle of hell, and not the first slide is presentation issues of this. So, what do you think? Will you proceed? Will you continue with other augmented reality apps?
Why not? It's pretty interesting. So we can go further, go interesting. Neural networks growing up and works faster and faster. So more interesting stuff might be done because right now the models get trained by our data science teams with other data science teams making more interesting models. One can detect, as I remember, there is model that can detect your illness by just scan of your eyes. Why not? It's really interesting area where we can go like to the stars.
Yeah,
I believe augmented reality application will grow a lot in the next several years, and not only from entertainment point of view, but also they would have also application in business, for example, showing some graphics in or charts in real life and so on. And it would be a new way for people to communicate with information.
Yeah, and today it's becoming a very hot topic because of recent presentations from Apple. Yeah, they presented the eyeglasses that also can use both virtual reality and augmented reality. It's kind of hype became soon, and good that you already experiencing this technology. So, by the way, according to your name of your speech, what's the circle of hell was the hottest? Let's say.
As for me, I was really surprised when I found out that neural networks IP in TensorFlow are not working according to documentation at all, and that we didn't make it working based on Stack Overflow, TensorFlow forum, and looking for TensorFlow issues. So I was really surprised with it.
As for
This
me,
was
maybe it's the part where you had to fix bugs, which is not your bugs. Like we, few times we even try to compile our own version of TensorFlow library. We digging up sources and try to figure out what's going on inside, how it works, because there are still places we can optimize and we can improve our performance. Even still, we talking. In my mind, there is at least few points that we can try to speed up even further.
Yeah, good that you mentioned TensorFlow issues and shared the truth, because recently I visited some conference and one guy shared how it's easy to apply TensorFlow. He shared some examples that posted on Android developers, show it not real life demo, but some demo that everything is working, everything is easy.
No,
I
no.
saw that.
Here we should count that applying TensorFlow itself is not a complex task. Just if you want to apply, but if you want some kind of really interesting results or hard processing data, like if you want really deep amount or huge amount of data from TensorFlow, this is where challenge starts. If it's just simple like predict network, then you feed some information and you get a really small amount of data, like just one line of text or a few digits. Yes, it's fine, it's really easy. If you want your model to predict images or generate something, as from our presentation, we had 8 megabytes of data per frame. This is really complex. And this is where you start hitting the points.
Yeah, guys, your experience is unique. I suggest you to share this talk on other conference, if possible for you. Yeah, if possible for your location or online. Share it everywhere. Share it on TensorFlow forums. Add your way how you implemented it. Yeah,
By the way, for TensorFlow forums, I have given feedback that none of the suggestions worked for us, and that we ended making a table and just brute forcing approach. We have several questions.
Yeah, guys. We have several questions. Let's proceed. Let's visit. Let me show it for you, Michał Szczepanik. Let's talk. What do you think is the biggest limitation for AI and AN usage on mobile devices?
If you don't mind, I will start from my point of view, and probably then Slava will say from his. From my point of view, it's basically a trade-off. You can have some small stupid model on mobile device, or you can have some great large model, for example, on mobile device or in the cloud. And after that, it's starting the trade-off. For example, if you're using it on mobile, you will have low performance. For example, it will proceed this one run of neural network for a large amount of time. If you're running it in the cloud, then you're using internet and you're paying for cloud computing. So from my point of view, it's basically it's basically a trade-off. What do you want and what could you have with it? How quick it would be, how large it would be, how lot of test data you can have to train it, and so on. And the second part of question, biggest limitation, probably on Android, it's the zoo of devices, because we have really lots of devices. It's not like on iOS. And you can optimize it, for example, for Pixels or for Samsungs or for Xiaomi devices. But there would be some devices that you are not covering. And for example, it wouldn't work there at all. It would either crash or work, for example, really slow, 100 times slower than on Pixel, on Flagman, and so on. So if to summarize, the biggest challenge is to cover all possible devices that you target.
Yeah, I'd say it a bit, I'd say cheaper way. So if you remember those diagrams, like fast, cheap, good, choose two. So the really similar stuff we can build for neural networks. It's work time, developer complexity for developers, and complexity of model. And you can choose two. If you want all three, so it works fast. So in this case, developers should be really experienced in huge amount of data. So like complexity of model, hardness for development, and work time or speed. It's really choose two.
Okay, guys. The second question is maybe not related your skills, but what do you think? Any words regarding the Vision OS?
We were one of the streams on this project, and another one stream was iOS. Honestly, I do not know the technical stack. I know that they're using Metal, and probably that's all. So sorry, I can't answer these questions.
No problem. Yeah, Martin, please ask this question on the second day related to Apple. I suppose guys prepared answer for you. So the question from Volodya Leskev, Lviv. Thanks for the interesting. So have you measured FPS only or some other metrics like battery usage, for instance?
Yeah, I guess this question for me. Yeah, I mentioned that we measure really the 3 points we measure the most is FPS at first iterations, because it was really important. Whenever we finish our optimizations and last circles of hell, we find out that those optimizations really affect battery usage, because if your frame process fast enough and use not energy heavy consumption operations, so the time in between frames is just skipped, and every skipped time is battery safe. So for example, Pixel 7 Pro able to render our image in 60 frames per second, but the device itself have option to be work on 30 FPS per frame. So we have few optimizations to skip or hold time in between frames. And this holding times, this time slot that not used to render, is really battery impactful moments. And yes, we measure battery usage. It's crucial for this kind of applications, because the longer you can use it, the longer you will have a good experience. And yes, it's important. Another kind of metrics we use is screen flashes. One of the latest options is about to how your screen work, how the slides swapping. It's called vertical synchronizations. We also measure these params on few devices. I'd say these were the most important metrics.
Don't forget about third one. How long can you hold device before it became too hot in your hand while testing application?
There was points that some devices became really hot, and though we have optimization to disable runs of our neural network based on few options, like if your face detector find out that your face really close to the edge, rest of the effects or parts just stops. And we're saying to our client that please move your face in the center, otherwise we can't do anything. I see you not good enough.
Okay, I have a question from my side. What do you think? What was the most important optimization for this app that you added?
If you remember, I said about using GLSL, it's compute shaders by OpenGL. And at first iterations, I can say we were too much experienced on working with them, and we not utilized the full power of these compute shaders. I'd say we used about 10%, maybe 12. And after digging dive in how it works, how we need to work, how to synchronize memory in between these groups, how GPU works, we able to use, I can't say 100%, but maybe 80 to 90% we're using right now. And it's a place where I showed on the frames that we start from 200 milliseconds and just down to 10 milliseconds, 20 times faster. It's, I'd say 70% of this increase were just because we optimized these compute shaders.
Okay,
Probably.
any issues you faced with OpenGL?
Oh, 1 second. The second optimization from my point of view is switching to TensorFlow from PyTorch and changing architecture of the neural network for the best fit. Probably it was the second one. Yeah, sorry for interruption.
No problem. I just wanted to follow up about OpenGL. Any issues with it?
You can ask Slava.
OpenGL issues. Yes, some devices like the fun stuff. If you remember, I said that we're processing 13 textures at the same time, and by official documentation, we might process up to 16 at the same time. But somehow, few Samsung devices has limitation to process 7. I don't know why. Why not 8? Why not 12? We find out that processing 13 at the same time, it might be complex because you can't pass all 13 textures. So we find out that instead of passing 13 textures, we can use 3D texture and just roll layers of 3D texture instead of having separate textures. yeah, it's increased complexity of the code, but we bypass these kind of limitations. Thank you to Samsung if someone hear me.
What was the most strange bug you faced?
It's probably there was few devices which when we switch in models from phase detector to second ones that generate those textures, sometimes TensorFlow crashes with out of memory error, and we had pictures where it used about 2 gigabytes of memory.
There was also one interesting bug when devices that that by documentation we are supporting OpenGL, yes, we are having crashes with logs like they are not supporting some versions, as far as I remember.
Yeah, we have it in the Firebase console that device not supported, and as final result, we just give a point that maybe someone just root device and remove something, or maybe it's another ROM installed on this device, and it's not a system because our QA team find out similar device and it will work fine. So this is assumption we made and just skip.
Yeah, guys, nobody said that it will be easy. This is Android. It's about pain, about hell, about everything. So, but we love it. Yeah. So I think we finished with our the latest talk. Thank you guys very much. It was really challenging and really interesting. I hope your presentation will see many people. All talks will be available after a week. I hope on this channel we cut some fails from these talks and present it in a good way. Yeah, thank you guys again. And who survived in this presentation and this day, please at 7 p.m. join. We prepared a special quiz related to mobile. It consists 13 questions related to topics of talks that guys presented, and of course related to our main topic today on Mobile People Community Day. It's about Android. And winner of this quiz will have a special prize. He'll choose a Udemy course for himself. We'll pay for it. So yeah, and after short break, we'll proceed with quiz. Thank you and see you.
Yeah, thank you for your attention.
Thank you. Bye bye.
Bye.